Problem number 6. So, draw the shear and moment diagram of the beam shown and determine the maximum shear and moment. So, ayan. So, ito, medyo mahirap na siya since triangular load na yung ating beam. Or triangular load na yung ating load. Ayan. Draw natin shear and moment diagram. So, ayan. So, shear, then moment. Shear and moment. Shear and moment. Okay na pala yan. So, ayan. So, first thing first. So, summation of moment tayo. A, B, and C. So, since tatlong segment lang naman tayo. Or tatlong point. So, A, B, and C. So, summation moment equals 0. At point C, clockwise positive. So, RA, assume ko as upward. Since yung load natin is downward. Times total length, 5 meters. Minus. So, area of a triangle. So, 1/2 times 20 kilonewton per meter. Base times height. So, ayan. 3 meters. Then, centroid. So, centroid, so, kapag papunta ka sa right side, or kapag sa increasing ka papunta, so, ang value natin dyan is 1/3. So, pag papunta ka naman dito, so, ito is equivalent to 2/3. So, 1/3 of 3. So, ito yan, 1/3 of 3. So, ito yung distance na yan. Plus, tayo ng value of 2, equivalent to 0. So, RA natin, equivalent to, and then value natin for RA. X times 5 minus 0.5 times 20 times 3 times 1/3 of 3 plus 2 equivalent to 0. So, RA natin is equivalent to 18 kilonewtons upward. Then next, so determine naman natin RC. So, summation of forces vertical na tayo equals to 0. So, summation forces vertical equals to 0. So, 18 which is RA minus, so triangle, so 1/2 times 20 times 3. So, hindi na natin kailangan ng centroid since summation of forces vertical equals 0 tayo. Plus RC equivalent to 0. So, RC natin, 18 minus 0.5 times 20 times 3 plus X equals to 0. So, RC natin, value is equivalent to 12 kilonewtons. So, ayan. Then, draw na natin shear and moment diagram. So, at point A, meron tayong support reaction equivalent to 18 kilonewtons. So, ito, 18 kilonewtons yan. So, ito, 18 kilonewtons. Then, from point A up to point B, so, determine natin yung shear. So, 18, positive 18 minus 1/2 ng 20 times 3. Times 3. So, meron tayong shear at point B equivalent to negative 12 kilonewton. So, point A up to point B, so negative 12. So, ano ba yung graph natin? So, ito, di ba? First degree na yan. So, ibig sabihin, dapat yung curve natin, or yung graph natin, is second degree na yan. So, balik tayo sa shear and moment diagram. So, shear, then moment, increasing, decreasing. So, ayan. So, ano ba yung load natin from point A up to point B? So, ang load natin is increasing. So, increasing, so it means dito lang tayo maglalay. Then, ano ba yung i-drawing natin? So, shear. So, it means ito yung ating gagamitin. Malungkot. So, ayan. So, from point A up to point B, so, meron tayong malungkot na graph. So, ayan. Then, next. Point B up to point C, so wala tayong load dyan. So, ibig sabihin, straight line lang yan from point B up to point C. Then, at point C, meron tayong support reaction, which is 12 kN. So, negative 12 plus 12 equivalent to 0. So, ito na yung ating shear diagram for the beam shown. Ayan. Ito na yung ating shear diagram. Then, next. So, under doon sa ating uniform varying load, so nagva-vary siya, di ba? Nag-i-increase. So, under niya, so meron tayong 0 shear. So, 0 shear. So, ibig sabihin, nandito yung maximum moment. So, nandito na-allocate maximum moment. So, dito na-allocate yung ating maximum moment. So, determine natin yung distance from maximum moment up to point, or yung location ng maximum moment to point A. So, determine natin value of x. So, paano natin siya ma-determine? So, di ba? So, based from geometry, area of a triangle is equivalent to 1/2 base times height. So, base natin is the distance and yung height is the load. So, ayan. Then, next. So, since triangle yan, so, eto, ibig sabihin, magkakaroon tayo ng separate na triangle pa. So, eto, x yan. So, eto is, tawagin natin siyang height of y. So, ganito mangyayari dyan. So, ito yung malaking triangle. So, 20 kN per meter. Then, ito yung 3. So, dito, yung distance nito is x. So, ito, tawagin natin siyang y. So, based from similar triangles, so, 20 divided by 3 is equivalent to y divided by x. Then, next, i-arrange ko lang yan. So, y natin is equivalent to 20 divided by 3 times x. So, ito yung na-input natin sa h value. So, y is equivalent to 20 divided by 3 times x. Then, next. So, balik tayo. So, ito, pwede ko na siguro ito burahin. Ito, pwede na. Ayan. Tira natin. So, area of a triangle, di ba, is 1/2 base times height. So, area. So, yung area natin is yung last shear. Ano ba yung last shear natin? So, last shear natin is equivalent to 18 kilonewtons, equivalent to 1/2. Yung base is yung x, times yung height is yung y. So, yung y natin, equivalent to 20 divided by 3 times x. So, it means dapat, yung ating value is less than 3 meters. So, kapag greater than 3 meters, so, mali na yung ating distance x. So, determine natin kung tama ba yung distance x na nakuha natin. 18 equivalent to 1/2 times x times 20 over 3 times x. So, x value natin, yan. So, 2.324 meters. So, between 0 to 3 siya. So, it means, tama yung x value natin. So, x natin is 2.324 meters. So, yan yung x value natin. Then next, determine natin yung moment. So, moment muna tayo dito sa location of 0 shear. So, pag moment tayo dyan, so ito, burahin ko na ulit yan. So, summation of moment at 0 shear. So, RA is 18 kilonewton times distance natin is 2.324 minus. So, minus itong uniform varying load. So, ilan ba yung ano natin dyan? Yung load natin dyan. So, 1/2 times base. Ano yung base natin dyan kanina? So, yung x, 2.324 times yung y natin is equivalent to, saan ba yung y natin? 20 over 3 times x. 2.324 times. So, centroid. So, papuntang right. So, 1/3 of 2.324. equivalent to, so ilan yung moment natin dyan? Minus 0.5 times 2.324 times 20 over 3 times 2.324 times 1/3 ng 2.324. So, ayan. So, moment natin dyan is equivalent to 27.885 kilonewton per meter. So, ayan. So, balik tayo sa ating mga diagram. So, kung naalala nyo, so, ito, decreasing na siya. So, shear, moment, increasing, decreasing. Malungkot, masaya, masaya, malungkot. So, ayan. So, since yung load natin is decreasing, so, dito tayo, then moment, so, ibig sabihin, malungkot pa rin yung ating graph. So, from 0 to 27, or, magpas, 27 point, ba't ito pala? Blue for a moment. So, ito, from 0, dito tayo dapat. So, 27.885. So, any moment natin. At maximum, at the location of maximum shear. Then next, at point B naman. Point B, burahin ko na ulit to. So, siguro naman, nakopy nyo na yan. So, burahin ko na yan. So, at point B, summation of moment at B. So, 18 times 3 meters minus 1/2 times 20 times 3 times 1/3 of 3. So, ilan yung ating value? 18 times 3 minus 0.5 times 20 times 3 times 1/3 ng 3. So, value natin is 24 kilonewton per meter. So, as you can see, so kung saan lagi na-allocate yung maximum zero shear, or kung saan na-allocate lagi yung zero shear, nandoon yung maximum moment. So, ayan. From 27.885, so, bumaba tayo na 24 kilonewton per meter. So, decreasing yan. So, dito pa rin tayo. Decreasing. So, 24 kilonewton per meter. Then, next, so, moment at C tayo. So, moment at C, since walang load dyan. So, di ba, wala tayong load dyan. So, eto, 0 degree. So, magiging first degree na tayo. 18 times 5 minus 1/2 ng 20 times 3 times 1/3. 1/3 ng 3 plus natin itong 2. So, moment at Z is equivalent to 0. So, ayan. So, from 0 degree to first degree na tayo. So, ayan. So, ito na yung ating moment diagram. Ayan. Moment diagram. Ayan. So, ito na yung ating shear and moment diagram. So, last, determine na lang natin yung maximum shear and maximum moment. So, for the maximum shear, so 18 to, then ito is 12. Tama, 12, di ba? So, it means maximum shear is 18 kilonewtons. Maximum moment, 27.24. So, 27.885 kilonewton per meter. So, ito na yung maximum shear, then maximum moment. So, that's all for problem number 6.